Okay, so in this part, we will use the decision tree from the scikit-learn to classify the iris datasets. Okay, so again, this is some of the parameter that the hyper parameter that we will be using. Okay, so first I have a blank file right here, and let me just kind of go here, and I think I'm gonna copy the imports again. So again, the first one is to import the utility functions or utility function that I have. I'm gonna use this one. It's okay. Yeah, this one's okay. And I'm gonna copy all the imports. Okay, like that. Hopefully, it will work. Take some time. Okay, so I need to rerun again, maybe. Yep. Okay, that works. Thanks God. Okay, so many problems with the new way of I guess new ways of writing files. Okay. Okay, so first I wanna kind of go through the setting up quickly because we already done this many times before. So I'm loading the data. So load iris, right? And then this iris is actually I think the array that contains many things, but I want to extract just the last two columns because the iris.data is actually the attributes that has 4 columns. So I want to select all the rows, and I want to select the third to the fourth columns. Okay, and also my y is the iris.target. So that is I guess so that is the y value. All right. So if I look at my no, not this one. If I look at my x, then yeah, I have I guess I have two-dimensional NumPy array that has 2 columns, and then y would be just one-dimensional NumPy array with a bunch of values, right? I also have 3 classes I wanna classify. Okay. Next is that I'm gonna split the data. We've done this a bunch of times. I use the train test split with the 30% test reserved for test data, and make sure that my random state is the same as my example. And also we want to split them so that the distribution of class is the same in both test and train sample. Okay, so do that. All right, so now my x just make sure that's the case. So if I do x test x train dot shape, I should get 105. I guess 30% of 150 should be 105. Okay, I guess if you remember, I guess iris, right? I guess x dot shape is 150. So we have 150 flowers, and then 70% of that is 105. Okay. Okay. So next we're gonna do standardization. So first we are going to make sure that our attributes has the same scale. So I'm gonna instantiate the object instance from the standard scalar blueprint, right? And then I'm gonna do the training. So training meaning that it goes into the attributes and find the mean and the standard deviation, right? So now my I guess object instance already know about the mean and the I guess standard deviation or variance of our attributes, and then I'm gonna transform it. Okay, so if I were to transform, so I'm going to transform xtrain into xtrain std, and also I'm gonna transform the x test because I'm gonna use them later on after I have trained my model. Okay. Okay, so next step is that I'm going to here. So I'm gonna use the parameters. So I guess something that I told you before, right? So if we just hard code the parameter just hard code them directly, then it's not tractable because if you wanna change things, then we cannot do that quickly. So the way that I like is that I like to include the parameter set. For example, this is the dictionary, right? It's called param set all, and it has a key that is the name of my, I guess, experiments. And then these are the dictionary that contains all this parameter that I want to use. For example, criterion, right? So it goes into this criterion over here, and I have a max depth, right? So this is the levels of the tree, the maximum level of the tree. This one, right? And then random state is something that I didn't use it here. I'll show you that I input it later on, okay? And also min sample split, right? So if I have a experiments, right now I have 4 experiments, and I want to choose maybe parameter called experiment 2, so then I can just do it right here, okay? And if I do it like this, then I can just okay, so then I want to get if I want to extract this value right here, I can just do like this, okay? So I guess this is another way of writing so that I only have this dictionary. So if I were to print the param values right here, then you can see that these are just dictionary, okay? So I have the ability to change maybe like experiment 3, and then I guess my dictionary that contain parameters changes changes accordingly, okay? So if I were to come up with a new experiment, for example, I might want to show you this one. So if I get max depth to be none, so that means infinite. So I guess just keep asking questions until the sample is pure meaning that you can split things perfectly. Then that's something that you might want to take a look at. Okay, so for example, so I can just keep increasing, I guess adding all the experiments here without having to delete anything. So that's kind of the nice thing that I want to do here. Okay. So the next thing that I want to do is that I want to come up with this one. Okay, so decision tree classifier. So these are the blueprint for the machine learning model called decision tree. So which we loaded from sklearn.tree. Okay, so it's this one right here. Okay, actually let me just it's kind of hard to let me just duplicate this one so that I can type for you. Okay, here. Okay, I can just close this one. I don't need this one anymore. Okay, all right, so I named this one right here, I named this one tree model. Okay, I just have to make sure that I get the name of the parameter right. Okay, so if I were to use just this, actually it works because it's using all the default value. Actually, before we go, let's make sure that you're aware of what are the default value, right? So if I search for this decision tree classifier in scikit-learn documentation, you can see that, for example, criterion is Gini, right? And then max depth is none. Okay, so if you don't set any max depth, it's actually none. And then the min sample split is 2, right? So if you wanna, I guess, inject all of this, for example, all of this inside into this class into this object instance, all you have to do is to spread it out like this. So I can do param value like that. Okay, so this is the way that you can, it's called destructuring. So destructure all of this back into all of this. So this is kind of nice because next, if I want to change, for example, ex5, right? And then I can just hit enter and rerun it. Then it will just change the parameter accordingly, right? If you want to check if the parameter actually changes, actually you can do that. So tree models, I think it's dot param or get param, right? Yeah. So there is a function that you can use to kind of see what the parameter is. So if you were to do this, then you can see that now my max depth is none, right? But if I were to change this to ex3, right, and then I rerun it, then you can see, oh, sorry, actually my max depth is 8, so this one is 8. So that's another useful function to use if you want to check if you have used the correct parameters or not. Okay, so something to keep in mind. Okay, and once you I guess once you're done with this, then you can I guess you can try training it, right? So it's gonna be tree model dot fit, right? And then you're gonna use x train std and y train, okay, right there. Okay, and if everything goes correctly, then it should work. Okay, working. So and once you train it already, then you might want to extract the the prediction, right? So you do tree model dot predict, right? And I'm going to use x test std. Remember, this is the test sample that we reserve. It's almost like the things that we coming from the future. So we don't use it for training. We only use for testing the model performance, although a little biased. Okay, so right now we'll talk about it later. Okay, and if you want to see the accuracy score, first I just show you how to do. If you want to see the number of I guess wait y predict dot sum. Okay, I forgot to run this one. Okay, run. So if you print this one, then this one is number of misclassified sample, right? Like that. So it's misclassified one sample out of, I don't know, 45 sample. Okay. If you want to see accuracy score, then you can do something like this. Maybe I'll just do this, right? And then accuracy score. Okay, so accuracy score. Accuracy score equal, right? I do accuracy score, okay, y test and y predict. So comparing the prediction from our sample and the answer, the prediction from our model and the answer. And if I were to print the accuracy score, right? So I would get something like this. So 0.97. So it's doing a quite a good job, right? So as I told you, this is quite a useful model to use, right? And if I were to plot the decision region, you can see something quite interesting. Okay. So if you can see that the I guess the decision surface or the decision line, right? You can see that it's always vertical and horizontal, and this is the artifacts from asking question one attributes at a time, right? If you can imagine, when you're asking questions, you are splitting each of the axes, right? For example, you might ask the question relating to the pedal width, if it's like greater or smaller, than that particular value, which is probably here. And then, so that is the horizontal lines. And then further questions you might ask might be relating to this pedal length, and that is probably at this point, which is greater or smaller or greater. And it's going to be the vertical line. And you might ask another question relating to the pedal width again, and then the pedal length. So the fact that you see all this corner is the question that we ask. So the more, I guess, the more jagged corners or lines that you see, the more questions that you were asking, right? So if I were to, I guess, reduce the max depth, you can kind of see that now I guess the decision line is gonna be less. It's gonna be more simple. So for here, so let me just do this. Max depth equal to 1, right? And then I'm gonna use exercise 1, and I'm gonna rerun again. As you can see, right? So right now it's only asked one question, so that's why you only see one horizontal line. So it's asking about the pedal width. That's it, right? If I were to change it into 2, then it's allowed to ask maximum of 2 questions. So you might see I guess it's asking the 2 questions from the pedal length only. But that's something that it was doing, deciding from the information gain criteria. Okay. I'm gonna go back to none because I want to see a little more complex, I guess, questions. So I'm gonna go to here where the max depth equal to none. I'm gonna rerun again. As you can see that there are, like many kinks and things that are happening, right? Okay, so I mean, this is fine for visualization, but for decision tree, there is I guess, even cooler way to visualize your trees. For example, you can use something called, I guess, plot trees function from scikit-learn. So this one, do I have it here? No, actually, I import it? Oh, it's actually here. Tree. This tree right here will have the function called plot tree. So I'm gonna copy the my code from my example, and I guess I don't need this one. I guess I need this one, so I might just copy something here. Write files. Okay, so I guess I need the one of the setup right here. So for this one, I'm saying that if I were to write file, I'm creating a folder called images, and then to keep the files. That's all. So I'm gonna rerun this one, and you will see that it's pretty cool. Okay, So for example, like this. Okay. So right now, I don't think I write anything here. So it's kind of hard to see. So I'm going to say write files to true. So if I set write files to true, it's going to save the image to this to the file system right here. Okay. And this one might be better to look at. Okay. Okay. Okay, so as you can imagine, so these are when max depth equal to true, equal to none. So that means that it allows to classify as many questions as it needed. And as you can see that there are many levels happening. Even though we only have 2 attributes, it can keep asking many questions from the same attributes too. Okay, so for example, as you can see here, the first question is whether the petal length is less than this values or not. So these are the scale value, right? So as you can see that it's split into two classes, right? The first one is the first class is 35. The second one is 70, right? And then this one is okay. So for this one, it can keep asking more because there are still classes that has not been separated correctly yet. So the second question is petal length less than or equal to 0.536 or not. And then it further split things into 2 classes. And then it keep doing that until in the end you have the I guess the perfect split. So all the classes have I guess the sample become pure, so it doesn't have any misclassification for the training sample. Okay. I want you to contrast this with when I set the max depth equal to 1, right? If I set max depth equal to 1, then you might be able to see this right here, right? 1, okay. And this is going to be EX1. I'm going to rerun again. Okay. Not this one. I want to go to here. And there you go. Just 1 question, right? That's it. And then as you can imagine that if you only ask 1 question, you're not gonna be I guess your accuracy would probably be lower, right? If I go back to my code, I should be able to see what is my accuracy. So it's only about 0.67, so it's not that good. Okay. I guess before we go, I want to show you another way of generating the visualization for the tree. Let me go back to my EX5 so that I have a lot of classification, a lot of questions. Okay, and there's another way that you can do, which is it's called the graph width packages. Okay, but this one is required installation of this packages, which I guess I show you in my note that you gotta install this thing right here. So I guess you don't have to do it, but as you can see from my I guess from my example, that is pretty cool. Let me show you. There you go. So I guess it's a very I guess nice looking visualizations. It's the same thing, which is it's splitting things here. It goes into this class, which is 35 samples. The rest goes in here, and it was asking another question at 0.536, and then it's splitting into this class, and then here it needs to ask further questions, and then it keep doing that until in the end you got all this class where n equal to 2. So as you can see that n equal to 2, that's kind of reminiscent of the I guess the parameter call, if I remember correctly. The parameter called min sample split. So we set it to 2. So that means that it's gonna keep splitting things. If it's greater than 2, it's gonna keep splitting. But if it's 2, then it's gonna stop splitting. So that's why this number is here. I can also do something, show you real quick, that if I set something, for example, if I min split to maybe 5, so I'm changing this one, and what's gonna happen, right? Okay. Okay. As you can see that yeah, it's gonna keep things into 5 most of the time, right? Not sure about this one. Kind of have to look into it further, but it should work. I'm not sure why it doesn't work, but yeah. But this is kind of small point. I think I'm not gonna go into this one. Okay. All right. So that's the way that you can use decision tree. And then next stop, random forest, which is another pretty useful one. Okay. I'll catch you later.